Okay, geometry, picking it back up. Quadrilateral, section 5-4. This is video number 2, picking it up after we go over what kite means. Hopefully you thought of some of the quadrilaterals that haven't been mentioned. One is the big one that everybody seems to remember, and that is a square. All right, a square kind of has all the properties of all the special quadrilaterals that we talked about before. So it's a parallelogram. Let's use the symbol, parallelogram symbol. It's a parallelogram that is both a rhombus and a square. It's both a rhombus and a square. So it's a quadrilateral. It's a parallelogram. It's got opposite sides parallel. Left parallel with the right, top parallel with the bottom. It's got all 4 sides congruent. It's got all 4 angles as right angles. So it's got the properties of a rhombus. It's got the properties of a parallelogram, properties of a rectangle. All right. Let me backtrack the kite for just a second. You got a note here. Because these 2 segments are congruent and those 2 are congruent, all right, 2 on the left, 2 on the right, note all rhombuses and squares are considered kites. Okay, so the only time that can be a little bit confusing is if they're like, hey, always, sometimes, never, a kite is a square. Yeah, sometimes it is. Always, sometimes, never, a square is a kite. And the answer is actually always. A square actually fits every one of these categories going above. If a kite is drawn like the one I drew in the diagram, that's not a square. But I could make a disjointed pair over here, and then a disjointed pair over here, and then all 4 of those ended up being congruent. That could be a rhombus, and that could be a square. It could be either one if I follow that pattern. So that can be a little tricky with those always, sometimes, never type questions. All right, so what if it's a special quadrilateral? Special quadrilaterals, but not a parallelogram. All right, so a kite might be a parallelogram. If it's a square or rhombus, then a kite is a parallelogram. If it's like the one that I drew as the example, then it's not a parallelogram. These last 2 special quadrilaterals, maybe you thought of these words or not. One of them looks like this. Let's go all the way across. I can go straight up on this one. One of them kind of looks like this. I just have one pair of opposite sides parallel. Anybody have an idea what that's called? That is a trapezoid. All right, a trapezoid is a quadrilateral, not a parallelogram, a quadrilateral, meaning it has 4 sides, that has exactly 1 pair of opposite sides parallel. Oh, I forgot to skip lines. It has exactly 1 pair of opposite sides that are parallel. So in this case, the top is parallel to the bottom, but clearly the left and the right are not parallel. And it doesn't have to be the top and the bottom. I could draw this where the left and the right, it looks something like this. And let's say like this. And I go way down here, shorter leg here. And I made this one parallel to this one. All right, that's also a trapezoid. It's got 1 pair of opposite sides parallel, but the other ones are not parallel. And the very last special quadrilateral I got to show you, that's why I drew that so big, is called an isosceles. Let me do this so you don't confuse it. Isosceles trapezoid. All right, an isosceles trapezoid. An isosceles trapezoid has 1 pair of opposite sides parallel and the other non-parallel sides are congruent. All right, so you have one pair of opposite sides parallel, the other sides are congruent. It would look something like this. All right, the top is parallel to the bottom, but they're not congruent. And the left is congruent to the right, and the left is congruent to the right. When you have something like this, there is different names given to it. The congruent sides are known as the legs. We've used that before with isosceles triangles. This is a leg. This is a leg. The parallel sides are known as the bases. Sometimes they call it like base 1, base 2, like B1 and B2. All right, and then we have base angles. The upper base angles congruent, and the lower, that's the lower base angles are congruent to each other. So it's basically because it's between parallel lines. Actually, that gets into some details that's in chapter 7 that I'm going to bring in here in a little bit. But along B2, you have two base angles. They're congruent to each other. All right, that's what I mean by the lower base angles, the ones by B2. And then these would be called the upper base angles. Anytime they tell you it's an isosceles trapezoid, they might say, and the legs are here and here. And that's to let you know which segments are congruent. You can use that in a proof or set them equal to each other if they got algebra on them. Same thing with the angles. So the lower base angles are congruent. The upper base angles are congruent. And what I was sort of stumbling upon just a second ago, I'm sort of mixing up my ideas, is that these lines are parallel. And so we could use same side interior angles. And so one of these angles on the bottom is a supplement of one of these angles at the top. There's same side interior angles on the right side. There's same side interior angles on the left side. So any angle of the top is a supplement of any angle on the bottom. All right. One lower plus one upper base angle equals 180 degrees. One lower base angle, one upper base angle added together, they're going to be 180 degrees because of same side interior angles. All right, that's going to wrap it up for my lesson for section 5-4. It's just learning the different names of the special quadrilaterals. We're only dealing with the four-sided figures, really. We talked about polygons in the beginning, but this is just focusing on these special four-sided quadrilaterals. Thank you.